IB Physics questions, day 28. The average surface temperature of Mars is approximately 20 Kelvin, and the average surface temperature of Earth is approximately 300 Kelvin. Mars has a radius half that of Earth. Assume that both Mars and Earth act as block bodies. What is the power radiated by Mars over the power radiated by Earth? Okay, so in our data booklet, we have an equation for power radiated by a body. So essentially, it is P of Mars over P of Earth. And that's what we're trying to find. So we can plug in values for this, and for the values that we don't know, they will cancel. So all we need to write is the A for area and the T for temperature. And well, area of a sphere is going to be 4 pi r squared. And even though it's half the radius for Mars, I am going to say r because I can say 2r down here. So I can say 4 pi 2r squared. And the 2r is being squared, so this is going to become a 4 when it's squared. But then I also have temperature. So for Mars, it's 200 Kelvin. So 200 to the power of 4. And then it's 300 to the power of 4 for Earth. So I can simplify this. These 4 pi's are going to cancel, as well as the r squared. So I'm going to be left with, well, this is going to become 4 times 300 to the power of 4, which is going to have 200 to the power of 4 as the numerator. I could write this as, well, it's going to be 2 times 10 to the power of 2 to the power of 4 over 4 times 3 times 10 to the power of 2 to the power of 4. And the 4, well, 2 to the power of 4, I can distribute this to get 16 times 10 to the power of 8, because 2 times 4 is 8. So it's this over this, which is going to be, well, 3 to the 4 is 81, I believe, times 10 to the 8, and this is times 4. So here the 10 to the 8's cancel. You're going to have 16 over 4 to the 81. You can simplify this further because 16 divided by 4 is 4. You have 4 over 81. Now, from the answer choices, you don't even need to know what this is exactly, because you can know that it's less than 0.2. So the answer is D, 0.05.